Read code number 79, word search. This is medium question. Let's get into it. Given onto the board and word, find the inner word used in a grid. The word can be constructed from whether of sequentially adjacent cell, where adjacent cells are those horizontally or vertically neighboring. The same letter cell may not be used more than once. Let's check with example 1. This is given word. So given word A, B, C, C, E. A is started from here, A, and then B, C, C, E, D. So return true. The second is S, E, E. S, E, E is here from start here, S, E, E, true. Then finally, A, B, C, B. A, B, C, but it cannot find neighbor, so return false. How are you gonna do? Yeah, just like we'll use the backtracking, and first we will iterate scan the all matrix, and then when you find the first letter of a word, we will start backtracking it. Then we will find the whole character of the word, we return true. Otherwise, we return false. Okay, let's implement the code. So first, we need to backtrack, and then we need the row and column, and then index of word. Initialize with 0, and then let's make the base cases. The return true case is if index is same as length of words, return true. Okay. This means when you find one by one and then found, and then index is located here. Out of index, this one is length word. Each means it passes the whole character of word, so that is the reason why we return true. And then next, while the find neighbor, we will check the this neighbor is in boundary of the matrix. If it's out of boundary or it is not the character we're looking for, we will return false. So if not, row is small equal than 0, and then smaller than length of word. So I will pre-calculate this one. M is length of word. This is number of rows. The N is length word, and 0. This one is number of columns. So I will use it. Then column is the same. The bigger equal than 0, and then smaller than N. And both row and column equals same as word current index. If this is not, we return false. And then now we start to backtracking. So if we did here, and then now we found this one, then we needed to the visited mark. So the reason is we did not move to next. So I will mark this one with the sharp. So next time, if the if looking for 8, it cannot find, because previous state either visited check updated 8 to sharp, so it cannot go in the backward. Okay. Okay, and then first I will store current character into both into character row and column, and then both let's the marking column mark with sharp, and then I will make a comment for other developer mark visited, and then I will iterate for direction. This one I will do the bottom up approach, so I need to pass the previous system stack status. So if back track now column index plus 1 is return true, I will return true to previous status, and then I will do for direction 3 4, then first now plus 1 to column plus 1, and then second now minus 1, first column minus 1, and then after finishing it I will reset both row and column with the character, and then if we cannot get any return, I will return first, and then let's iterate to let's scan the matrix, and for row in range n, for column in range n, and then if both row and column is the same as word 0, then we will run DFS, not DFS backtracking, pass row and column. If that is true, then I will return true because we found the character. Otherwise, return first. Okay, looks good. Awesome. Okay, let's check the time complexity. First, here it take m multiply n to scan whole of the matrix, and then when you found the word, I will start backtracking. At that time, this one the searching for direction, so this one is same as 483. So time complexity is big O n multiply n multiply 4 to the L. L is length of word, because this one is A is the direct searching for direction. This one also for direction. So time complexity is big O m n multiply L 4 to the L, and then the L is length of word, and then space complexity just big O L, because it just using the same depth length of word as the system stack of backtracking. Thank you.